There's nothing like the sound of a car engine starting, especially when it's 15 below on a winter morning. Today's automotive batteries are smaller, more powerful, and more efficient, even at extreme temperatures. It's all thanks to the power of lithium-ion cell technology. While dissecting a frog in 1786, the Italian researcher Galvani noted that when his scalpel touched a leg muscle, it contracted from an electric current produced. Later, Volta believed the current was produced by the metal instruments, the animal being only a conductor. To prove it, he stacked discs of zinc and copper, connected by conductors and fabric, impregnated with an acid solution. And so, in 1800, the electric battery was born. Batteries power all kinds of electric motors. A new lithium metal polymer battery pack such as this one could soon power an electric automobile, as well as a hybrid vehicle. This battery will be made up of 4 components. It all starts with this lithium ingot, which weighs about 11 pounds. It is transformed into a thin sheet by this extrusion press that applies 440 tons of pressure. The press creates a sheet that's only about 1/100th of an inch thick. The whole extrusion sequence is closely computer controlled. Extrusion is now completed. The metallic lithium sheet is the required 1/100th of an inch thick. The sheet has to be further thinned. Placed on a roller, it is carried to the laminator. At room temperature, it is thinned once again. In just 20 minutes, the 11-pound ingot will have been transformed into a thin sheet 0.01 inches wide and some 655 feet in length. This laminator completes the thinning of the sheet. The resulting 1¼ mile long sheet will allow for the fabrication of 210 battery units. Lithium is a soft, sticky metal. For this reason, a polypropylene film has to be fixed onto the lithium sheet. Without this protection, the sheet would adhere to itself and become unusable. The sheet will be used to make individual battery cells. Then these cells will be assembled in series and in parallel and inserted into modules of different shapes. To make an individual battery cell, the sheet has to be rolled up. This automated spooling machine winds up the lithium film in 26 revolutions. The wound-up sheet is put into a vacuum oven, where the various layers adhere firmly to one another. This step lasts for about 90 minutes at 176 degrees. Here, a test is made. Using a voltmeter, the battery is checked to see that it produces the required 3.56 volts. Any problem can be detected here and corrected. A final quality check is made with this caliper. It precisely measures the thickness of the battery cell. The battery cells are then stored. Metallic plates are placed between them for the entire storage period. One more step remains, and that's the metallizing of the contacts. The battery cells are sent off to a fabrication facility in this container. The container is robotically handled. First, it's put into a protective tank. Then, the metallizing of the contacts is done by spraying on molten metal. This takes just a few seconds since the metal cools very quickly. The battery is now finished. It is comprised of 4 elements: lithium, which acts as the anode, a metallic oxide cathode, a dry solid polymer electrolyte, and a metallic current collector. All that remains to be done is the assembling of the individual battery cells into a module. It begins with the placing of individual cells onto one another and isolating them with foam so that they do not touch each other. These red sheets are actually heating elements, since the lithium metal polymer cells function at temperatures of between 104 and 176 degrees. Here we see these modules of a battery pack for a hybrid vehicle, an automobile that works with a gasoline-powered motor and an electric motor. This prototype battery was created for a totally electric vehicle. It surpasses heavy traditional lead-acid batteries that can't develop the same amount of electrical energy and have much shorter lifespans. There's nothing like the sound of a car engine starting, especially when it's 15 below on a winter morning. Today's automotive batteries are smaller, more powerful, and more efficient, even at extreme temperatures. It's all thanks to the power of lithium-ion cell technology. While dissecting a frog in 1786, the Italian researchers